Hi everyone, I'm back with another practice example, but this time in signals and communications. You would take this course in a second year or third year of computer engineering or electrical engineering, definitely electrical engineering. And then you might be an applicant for P.Eng who would need to take a technical exam, and this is one of your options. So let's dive into it. This is basically on the Fourier series topic, and then it asks, consider a signal that is a periodic pulse train as in the following figure where the duty cycle is 25%. If the amplitude of xt is a, then give an expression for the third harmonic of the signal in terms of the signal parameters. Okay, this question specifically asks for the third harmonic, but we are going to write the full Fourier series so we can practice together and then understand the whole topic basically. So when this, the important part is that when it says the duty cycle is 25%, so duty cycle is 25%, then, or 1/4 in terms. So that means from 1/t, we only have, from 0 to t, basically we only have 25% of the signal to be non-zero. And then, or from minus t/2 to t/2, this width is basically t/4, which would make this side to be minus t/8 and this side to be t/8. Okay, so now let's write the Fourier series because we want to practice the whole topic. Xt in terms of Fourier series is a0 plus summation of n from infinity an cosine 2 pi f0 tn plus bn multiplied by sine of 2 pi f0 tn. Okay, and then where here f0 is 1/t, and it's the fundamental frequency of the signal. Okay, now we have a little bit of easy case here, because if xt is symmetric compared to the center, or in other terms it's an even function, or mathematically we can define even function as x minus t is equal to xt, then the odd part of the Fourier series goes away, and that's the sine function. The sine function, because the sine functions looks like this. It's an odd part of the Fourier series, and then we can say that bn would be 0. On the other hand, if xt was an odd function, what does that mean? Mathematically, it means that xt minus t was minus xt, then a0 and an would be 0. These are the even parts of the function, because cosine is the even part. It's symmetric. Okay, so now we are dealing with this case where we have an even function, so bn is 0. Okay, so let's find a0. a0 is 1/t of minus t/2 xt, and then this is dt. Okay, we can think of it as multiplication of cosine cosine when n is 0, which is 1. So here the same thing would happen. Now we know that xt is only non-zero between minus t/8 to t/8, and the value is a. So this is because of the duty cycle. Don't get duty cycle. I have a problem with cycle. Okay, a dt, and then that would make it 1/t a 2 multiplied by t/8, and that would make it as a/4. Perfect. Then we have an, which is 1/t minus t/2 xt cosine 2 pi f0 n t dt. Again, because of the duty cycle, we have a case of only 1/4 of the cycle is non-zero, or A, and then cosine 2 pi f 0 n t dt, and then this would become as 1 over t A, then 1 over 2 pi f 0 n, then sine of 2 pi f 0 n t from minus t8 to t8. This is equal to at 1 over 2 pi f 0 n multiplied by 2 sine of 2 pi f 0 n multiplied by t over 8. Now f0 and t would cancel each other out, and then so in that case we would have an becomes a 2 pi n, oops, actually we have another, so let's f0 and t are reverse of each other, 2 goes away, so we have a pi n sine of pi n over 4. Okay, so in case of A3, we would have the third harmonic to be a 3 pi sine of 3 pi over 4, or minus square root of 2 over 2a over 3 pi. This is the third harmonic. The value of the third harmonic. The third harmonic of xt is going to be a3 multiplied by cosine 2 pi f 0 t 3, which is going to be minus a 6 pi cosine 6 pi f 0 t. Now let's go. It says B, determine the average power of signal xt. So since xt was written in terms of the Fourier series here, we would have it as so the average power of xt is going to be a0 squared plus 1 over 2 of an squared, and this is because we have the 1 over 2 because it's the cosine, and this is basically a DC signal, so it just multiplies by itself. And then so then average power is going to be a over 4, because we found a to be a0 to be a over 4 squared plus 1 over 2, then summation of here an, which is again a over pi n squared sine of pi n squared. You can try to do a little bit of, you know, factoring a and stuff like that, but that's it. This is the most we can do for now. And then the third part, it says determine the duty cycle so that the amplitude of the third harmonic is maximized. This is a very interesting question. Okay, so we found the third harmonic when the duty cycle was 25%, right? Let's do an again, or a3 again, but this time we are going to consider the duty cycle to be a variable as r. That would mean that the non-zero part, a0 non-part, or t0 non-part, sorry, the duration that is, or the width of the signal to t is going to be r, okay? The width of the square pulse. So a3, let's write it again, is going to be 1 over t minus t over 2, then xt, which is, let's write it as xt for now, xt, then cosine 2 pi f0 t multiplied by 3 dt. Now, since our duty cycle is r, then w, this is going to be turned to 1 over t minus w over 2, the width of the signal, a, cosine 2 pi f0 t 3 dt. Then here we can write it as minus rt over 2, and then this is a cosine 6 pi f0 t dt. Then this is 1 over t multiplied by a, 1 over 6 pi f0 sine of 6 pi f0 t, when this is minus rt over 2, so it's going to be a 3 pi sine of 6 pi r over 2, right? Then yes, because f0 and, did I write that right? Yes. So now, in order to maximize this part, a over 3 pi is a constant. So the only thing we can maximize is sine of max of, let's write it this way, max of sine 3 pi r over r. I'm just worried I made a mistake here somewhere. I don't think so. Sine 3 pi r is 1 when 3 pi r is equal to 1 over pi over 2. Because sine becomes a 1 when the variable in front of it is pi over 2. So we can say r has to be 1 over 6, or 33, or 13%, basically, something like that. 13%, about 13%. So this is, we found it. Now it asks, determine the average power in the third harmonic in case of C. Perfect. So now we can say the average power of x3t basically is going to be 1 over 2 a3 squared, which is 1 over 2. We said when, so in this case, what becomes a3? Sine becomes 1 because it's maximized, and a over 3 pi. So perfect. So we can say a over 3 pi to the power of 2. Then it becomes a over 2, 18 pi 2. That's the maximum. Okay, I hope you enjoyed this solution or this practice example. You learned something, and come back for another video. Thank you.